Hello everyone, my name is Mahboubeh Ghasemi. I'm a mathematics teacher in the Ministry of Education with 22 years of teaching experience. In this video, I will solve a mathematics Olympiad problem for you step by step in a clear way. Let's get started.
In this video, we'll build a precise diagram and solve for the radius and the area of a semicircle. The semicircle lies inside a rectangle with its curved arc tangent to the top and the right sides. The flat side is a slanted diameter, AB. Our goal is to find the radius and then the semicircle's area. Let's draw the diagram exactly as described. 1. The outer shape is a rectangle, not a square. 2. Inside it, a semicircle. 3. The arc is tangent to the top and to the right sides. 4. The flat side is a slanted segment, AB, which is the diameter of the circle and not a diagonal of the rectangle. 5. Point A is on the left side, 8 units below the top left corner. 6. Point B is on the bottom side, 4 units left of the bottom right corner. 7. The center C is the midpoint of AB. We will model this with coordinates. Let the rectangle corners be at 0, 0, W, 0, W, H, and 0, H. Point A is at 0, H, minus 8. Point B is at W minus 4, 0. Since AB is a diameter, the center C is the midpoint of AB. Because the arc is tangent to the top and to the right sides, the distance from the center C to the top side equals the radius r, and the distance from C to the right side also equals r. From the top we get r equals h minus the y-coordinate of C, which simplifies to h plus 8 divided by 2. So h equals 2r minus 8. From the right we get r equals w minus x-coordinate of C, which simplifies to w plus 4 divided by 2. So w equals 2r minus 4. Next, the length of AB is the diameter, which is 2r, using the distance formula between A and B. We have 4r squared equals open parenthesis, minus 4 close parenthesis squared plus open parenthesis, h minus 8 close parenthesis squared. Now substitute w equals 2r minus 4 and h equals 2r minus 8 and solve for r. With r equals 20, the top tangency point is directly above the center at a distance 20, and the right tangency point is directly to the right at distance 20, matching the diagram perfectly. Now compute the area of the semicircle.